So say this red line is the ground right here. As you're taxiing to the runway, it probably should take 20 miles per hour at most. But the thing is, most commercial aircraft, like this right here, but also this right here, say that they fly 500 miles per hour. But the problem is, there are two variables. The two variables are ground speed and airspeed. When they talk about 500 miles per hour, the airplanes or the pilots are measuring with the ground speed. So the altitude is going to matter how much ground speed there is. Usually, when the plane is on the runway, it takes around 150 miles per hour. But when it's around like 1,000 feet, it's 200 miles per hour. But as they get close to the cruising altitude, around 28,000 feet, it's going to be around 500 miles per hour. So when you measure from ground speed, you're only measuring like how fast the plane's going according to the ground. The airspeed is a little bit different. The airspeed is talking about how fast the airplane's actually going in the airspeed. This is going to be measured in knots. This is why they say that an Airbus A320 will be able to take off with a minimum of 120 knots. And they use that when they're actually in the air during the cruising altitude. They still use knots. But if you're on a TV, if you're on a plane with TVs, like if you're on JetBlue, for example, yeah, this kind of plane, if you go into their information, it will say how fast the airplane is going with ground speed and airspeed. So, about the International Space Station, when they say NASA is explaining that the thing flies at 17,000 miles per hour, that is according to that ground speed. There is no possible way the ISS is flying that very close to the ground. But that thing is like in space, so there's like a very high altitude. The airspeed is a little bit different. So that's why when they say true airspeed, they're talking about how fast the plane's actually flying measured in the sky, not referred to the ground. So the next thing we're going to take a look at is the air density. So what if I told you that if you look at the dashboard on your JetBlue airplane, if it has like TVs or a giant aircraft like this one right here, it will say the temperature outside the airplane. But as you notice the airplane is increasing in altitude, the outside temperature on the plane is going to be colder every time it goes way up there. Going back to our ground scenario and our airspeed scenario, say this is the ground and this is space. The thing is, there's less air pressure when you get close to space, because space, there's a vacuum and it gets very cold up there. That's why if you're here on the ground, it's warm. But as you go up, the temperature can get close to like negative 30 degrees Fahrenheit. So the air density, the temperature, and how much pressure is on the airplane is going to affect how much lift is on that airplane. And the last one is the most difficult to understand, but it'll be simplified. Lift coefficient. So, the lift coefficient talks about the overall design of the airplane's wing. This is excluding the surface area of the wing. So there are 3 things that affect the lift coefficient. There are more things, but these are the biggest ones. They are how the airplane is designed to go towards the wind, how it's going this. So basically, the curve of the wing, the design of the wing. For example, a fighter plane is going to have a different kind of wing rather than a commercial airliner, because fighter planes usually are a lot faster. And the third one is the most complicated ever, but it's called the angle of attack. So we'll need a graph to understand this. So when the wing goes at an angle, it's usually tilted up or down to control how much air pressure there is on the plane and if it generates lift. So when you talk about the angle of attack, the 0, 2, 4, 6, 8, 10, 12 is how many degrees the wing is going to be pointed at. And the CL on the y-axis is going to talk about the lift coefficient. But there's a catch. If I put this in green, from here all the way to the crest is going to be good because the lift is going to outweigh the gravity on the airplane. And the wing is at an angle where it's able to catch all that air and create pressure on the bottom of the wing, causing it to move up. But sometimes if you do it too much, then there's going to be some problems. As you go increase down here and get to this red area here, this is where the wing stops generating lift and air pressure, meaning the airplane stops flying, also meaning the airplane falls to the ground. So when you engineer an airplane, it's a good idea to measure the wings of the airplane and how to understand what the angle of attack is and how it affects it. It's a good idea to test it in a wind tunnel. Yeah, it's a pretty good idea. And that is how we understand the lift equation. I hope this video has helped you understand the lift equation. Thank you for watching Top Fingerlines Math Industry. Like and subscribe.